Okay. So wait up just another minute and then I'll start my chat. Okay. So so hi to anyone watching here or offline. Um, so I wanted to do this jamming session for two reasons. First thing is that we sort of finalized and made a few changes in our MOA code, and I just wanted to go over it and walk through the structure of the code and look at what changed, just so you guys would be more familiarized with it. And other than that, we've made kind of a significant change on the way that signatures and hashing and transaction hashes work in the MOA account. And we did that to enable implementation of dApps based on the new MOA contract, and we've made it. We hope we made it generic so that it would work with any wallet. So we mean that the MOA account could have several owners, and they could come from a variety of different wallets. So it shouldn't matter which one. And we hope we achieve that. So I'm going to share my screen, and then we can have a look at, I'll move over here to the code. Okay, so a little bit about the structure of the project. So I'll just close all this stuff. Okay, so generally this is a pretty standard Cairo 2 project. Has the SCARB file and a bunch of other relevant things specifically in our repository. We use Python for the end-to-end tests. So we have the requirements file for that. And inside here, we have the source folder, and it's also pretty standard. And specifically, what we use is the component, the component design pattern that we see in the Open Zeppelin Cairo accounts, where we try to have most of our logic divided up in different components. For example, in Open Zeppelin contracts, we have the upgradable component, the posable component, owners, whatever. So we try to have that as well. We have components for for signing and for handling multiple owners and so on. So we have several of those. And the presets folder is where all these components get combined together into a contract. So for example, the Braavos MOA contract is the account contract of our multi-owner account contract. And it compiles just a bunch of different components, like an introspection one for interface IDs, handling the multisig, handling the different signers we have, and other logic. So all this code is, by the way, in the repository I've sent earlier on Discord, so you can access it over there. Yeah, so this is the Braavos MOA account. Other than that, the interesting parts are concerning the ABI of this account. So I've went over this last time. This actually hasn't changed, but just a reminder that previous in the previous talk, I've discussed how one would propose the transactions and how one would sign them. So we kind of divided the owners of the MOA account into two parts. So we have the proposer and we have the verifier. All of this is recorded, so you can access everything we've said before. So just as a short reminder, we have the proposer account owner who suggests a transaction to execute. And then we have a cascading process where other owners of the account sign on this transaction. So the first one is called the proposer, and the second one is called, and the other following signers are called the verifiers. And what I've mentioned at the time is that to be a proposal of transaction, for example, you want to transfer some tokens, then you would need to prefix the calls you'd like to execute. For example, your transfer call with a special kind of call that we have in our account. So where can I find it? Oh, it's here, sorry. So our account has two special calls, and whenever a proposal owner would like to send a few calls, they would need to prefix all these calls with a call to assert max fee. And it would like to, and in this call, they have to set the different fees they expect in this account. So they have to limit the verifier max fee. So malicious owners of the account will not drain gas when they are signing transactions. And the proposal also sets a certain max fee on the execution of the transaction, which is, of course, expected to be higher than the signer max fee, since the signer max fee is just a call to is valid signature on one of the owner accounts, where the execution max fee is for actually executing all the calls. This assert max fee doesn't actually ever get executed. It panics. It in fact is just popped out of the list of calls when execution time arrives. Um, so so the proposer needs to prefix this to every list of calls they'd like to execute. A verifier needs to call something called sign pending multisig transaction, where they need to set the different parameters of the pending transaction, like the nonce of that transaction and the ID of the proposer and the list of calls. So that's how it works, and you can have a look at we have a pretty extensive end-to-end list of Python tests for the MOA, and you can review them and have an idea on how this this contract expects to be interacted with. So that's one thing. And the second thing is, which is really important. So I wanted to talk about how the hashing works. So we know that a multi-owner account has many owners, and they can be a different kind of wallets. And one of these owners can propose transactions and the other verify them. And the question is, what do the different signers actually sign on? So what's the hash that everyone signs on? And one option, which was our first approach, was just to sign on the hash of the first transaction, the one that the proposer chooses. But that has different complications, and it kind of makes it hard to work with different custom wallets. So our current approach that we use, so we're using SNP 12 at the moment, which is like the hashing standard for different data structures. So what we do, we generate a certain struct that has all the informations that are relevant for the spending transaction, which is being proposed, like the nonce and the ID of the proposer and the list of calls. And then we just hash it according to this standard, according to the SNP 12 standard. And then we just, you can do it with Starknet.js or whatever. We just ask the current wallet to sign on this hash. And that's about it. This hash is sent over, and every time one of the verifiers wants to sign on something, they would calculate this hash. They would request the wallet to sign on this hash, and on this message, and that's and then the signature would be sent. And we think that this would be a generic way and a great way to implement different dApps. We have several tracks for this hackathon, and one of them would be to develop some kind of dApp that could interact with the MOA contract. And we think that this would allow anyone interested to implement this dApp and interact with generic wallets. So we have a few examples over at our test files. So you could have a look at that. You can also have a look at how this this also exists in our repository. So you can have a look at how hashes are being calculated. So it's pretty standard. All these strings and whatever are from the standard. We have a file called mo8tx hash, and you can follow along and see how it's being calculated. Yeah. So you're asking if these are governance tools. So this is a multi-owner account. It can be, I guess, using it as a governance tool makes a lot of sense. But it can also be used as a collaborative tool in dev teams and so on. So that's one option. But yeah, definitely implementing some kind of governance tool would be a cool idea for the hackathon.
Using this technology. Can I speak? Sorry.
Sure, go ahead.
Because I was late. I'm very sorry.
No problem.
Uh, so I was looking on the GitHub and I saw the snips are tools for from Starknet, right?
Yeah, snips are different standards defined in the
Okay. Okay. Okay, I'm gonna study this repo and then maybe come back with some questions. But yeah,
Perfect.
my idea was start with some DeFi protocols, and because we have two tracks for DeFi protocols in the hackathon, so I was thinking of joining more than one track, and yeah.
Good. So sure, if there are any specific questions, you can ask and on the Discord, for example, and we can also hop on a call once there's something more.
Use your wallet. I started with your wallet, so I was going to keep using it.
Awesome.
The MOA account.cairo is a smart contract,
Yeah.
right?
Yeah. It's based on the current on like the newer version of the Braavos account, the one for Cairo too.
I'm looking for it on your GitHub. Okay.
Yeah, so I sent a link on Discord. You can that repository has the actual MOA
Thank you.
station.
Oh, okay. And now I see it. Yes, you sent it 2 days
Yeah.
ago. Thanks.
We do have the version on GitHub, which is the audited consumer account. The one with MOA is still in progress. So I have that on a different repository.
Okay. Okay. So I'm gonna let you finish because I don't wanna interrupt it
Okay,
too much.
I'm done for this call. Just wanted
Okay.
to update, just to have a look
Yeah.
at the code and just to update on the new hashing format. And yeah, that's it on
And my question was more about a governance tool, because I was thinking of creators funding the projects for themselves, maybe using some DeFi yield mechanic, and allowing people like a DAO does, okay, voting for projects and allowing people to get the yield of their DeFi investments.
Yeah, that could be a good idea.
You think it could? Okay. Because if I use because I was today I was looking at the Nimbora strategies, okay, and they have this way of sharing the strategies. So many people can join a strategy, a yield strategy, DeFi yield strategy, but the distribution of the yield is not managed. So maybe I can use your MOA to to distribute the yield in a structured way. Yeah.
Okay. If you have any reading materials, I'd be happy to go over it.
Okay. I think I'm gonna post on the Discord. If you don't have a Braavos Discord specific for your project, otherwise, if you have a Discord for Braavos, I'm gonna join it.
Yeah,
Maybe.
on the Layer X Discord, there's a channel for Braavos.
Yeah, but okay, I'm gonna ask that. Thank you so much.
Okay, sure.
I'm gonna send the documents there so that you can read. Okay.
Sounds good. Okay, so thanks everyone for tuning in. And
Thank you.
tomorrow we have debugging sessions. So if anyone wants to log any of those, you're welcome. Okay, bye everyone.